Let's start our discussion on 2.4. We've covered so far how to find the limit of a function numerically, graphically. Let's talk a little bit about algebraically, some of the approaches that we're going to run into. I'm going to quickly go through this, not in too much detail. Let's say we're taking a limit as x goes to some value of some function. Let's say we have a second, third, fourth function. It doesn't really matter. Let's work with 2. We know the limit of each one of these functions, right? One goes to L, one goes to M. Remember, these are just some numbers. If you happen to know the limit of a function and you know their values, if you add those functions together, all you need to do is add their values together. Same thing is true for subtraction, right? Multiplying by a constant, multiplying together, dividing, as long as you're not dividing by 0, and raising to an exponent or taking some type of root. So, just kind of exploiting these rules a little bit, let's look at some information that we have, right? So, what we need to know, we have 3 functions. The limit as x goes to 2 of f of x is 4. The limit as x goes to 2 of negative 5. And the limit of h of x as x goes to 2 is 0. Let's be kind of clear about one thing. In all of these definitions, x does need to go to the same value in order for this to hold true. So, just kind of playing with the rules a little bit, essentially we can think of being able to distribute the limit around as a way that some people like to think about this, right? So I can take the limit as x goes to 2 of each piece of this one by one, right? So the limit as x goes to 2 of f of x plus 5 times the limit as x goes to 2 of g of x. Basically, if we know a thing or two about these functions already, then we can combine them in so many different ways and just use the information that we already have, right? So, the information that we have the limit of f of x as x goes to 2 is 4. So I'm just going to substitute that in. Plus 5 times, right? There's that 5. Times the limit as x goes to 2 of g of x, which we know to be negative 5. We combine all those values and we get negative 21, right? So basically we can build new functions from old functions and their limits flow with them nicely, right? So even if we take a function and we cube it, right, its limit as x goes to 2 of g of x, essentially we get to do the same thing to that value. So negative 5, which was given, we're going to cube it and we get negative 125 for our new limit, right? So same thing is true for these division problems. The limit as x goes to 2 of the top divided by the limit as x goes to 2 of the bottom, which we've done a little bit of this in the previous section. A lot of this is kind of going on in your brain. Substitute what you know in, you get negative 5 over 4. Right? The only cases that you have to be careful of are ones like this one. The limit as x goes to 2 of 1 divided by the limit as x goes to 2 of h of x. If you take the limit of a constant, you're just going to get that constant out. There's no x variable to plug anything in. It's going to stay. But for this bottom portion, we do get 0. We haven't talked about this just yet. Being infinity, we'll talk about this later. It's just easier for us to kind of conclude that now so we can get in the habit of not doing this and jumping straight into the D&E case, right? Because we've talked about kind of being careful of that. Same, last but not least, the limit as x goes to 2, right? I can just take the square root of what I know, even if I'm taking the square root of the function alone, which was 4, and we get 2. Remember, we don't want the plus or minus here. We want one nice answer. I did want to add one last example, A, B, C, F, right? If I wanted to change, let's say we change this last one just a little bit as x times this. Essentially, x is just a constant, right? Where this really comes into an advantage, this algebraic approach that we're going to look at on the next page, is when the value is in fact in the domain. If the value is in the domain, essentially we can just plug these numbers in for x. So what do we know? We know that x is 2. We got that from the x goes to 2 part notation. And we know the square root of f of x was also 2 from the previous problem. So we get 4 back. Right? So just kind of looking out for stuff like that, where I find there's a really big advantage. I'll let you guys try that problem.